Hello everyone. Today let's look at some basic concepts regarding the numbers. So whenever we talk about the numbers, the first and foremost thing that comes to our mind are the base part. The basic of a number is a digit. How many digits are there? Yes, we have 10 digits. And those 10 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 digits altogether. In our number system, these are the 10 digits. Now you use these 10 digits and form some numbers 456, 8273. So we have combined some of these digits and we formed some kind of numbers. These numbers are typically called as numerals. Any number that you are forming using some combination of the digits is called a numeral. Now, depends on where these digits have been placed. Each of the location of the digit is actually called as the place value. We have a numeral. The numeral consists of digits and depends on at what location the digit is present. We call that as a place value for that particular numeral of that particular digit. So typically we know the basics part. So this is the ones place value. Then we have tens place value. Then the place value is 100. Then thousands, 10,000s, a lakh, and so on. So the place value, you could see if I go from the right to the left, the place value of each of the digit that is before it, that is to the left of it, is 10 times the place value of the digit that is there to the right of it. So that is what we typically call as the place values. Then we have two important systems or the methods. Two important methods in which any numeral can be represented. One is generally the Indian system which we use, and the other one the international system which is generally followed in United States and various other countries. So let me take a big number. That's a very simpler way to understand the whole thing. So let me take a numeral 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1. It's a big number that I am taking. So if I have to represent that in the Indian system, so this place is called as the units place, the tens place, the hundreds place, correct? This is the thousands place, the 10,000s place, this is the lakhs place, 10 lakhs place, crores place, 10 crores place, Arabs place, and the 10 Arabs place. So these are the places for the various digits written at different positions. So, and in the Indian system, there are there is a kind of a separation which we generally put with a comma separated. So these three, it's one group. Then the thousands are one group, so 78,000. The lakhs and 10 lakhs are one group. Crores and 10 crores place is another group. Arabs and 10 Arabs place is another group. So typically this I will be reading as 12 Arabs, 34 crores, 56 lakhs, 78,901. So these are what each of these groups is otherwise called as period. Each of these groups is otherwise called as the period. So we are starting with the units, tens, hundreds, thousands, we have the lakhs group, we have the crores group, and we have the other Arabs group. And we put generally commas for each of these groups. So the first comma is after 3 digits in the Indian system, and after that for every 2 digits we get a comma. So that is how we typically read it. Then if I look at the face value of 1 here, the face value is 1. The face value of 0 is I multiply it with 10, so it's 0. The face value of 9 is 900. It's in the hundreds place. The place value is 900. The place value of 8 here, which is in the thousands place, is 8,000. The place value of 7, which is in the 10,000s place, is 70,000, and so on. So that is how we get the place value. The place value of 1 here is 10 Arabs. So that is what we call as the place value. The place value is you take the digit that is there in that particular location and you multiply it with the corresponding either 1 or 10 or 100 or 1000 and so on. Whereas there is another term that we generally use called as the face value. The face value is the digit itself. The face value of this 9 is 9 only. The face value of this 4 is 4 only. Whereas the place value of this 4 is 4 crores because it is there in the crores location. The face value is 4 only, whereas the place value is 4 crores. So the place value changes, an important point for you to remember. The place value changes depending on where exactly the digit is in that numeral, whereas the face value does not change. Wherever, in whichever location it is, the place value changes, but the face value does not change. So again, for a simplicity, I am reiterating. Let me take a number 12,345. The place value of this is 10,000, but the face value is 1. The place value of this digit is 2000 because it's in the thousands place, whereas the face value is only 2. Coming to this 4, the place value is 40 because it's in the tens place, whereas the face value is just a simple 4. So that is what is the Indian system of representation, right? So again, let me take the same number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1. So we said in the Indian system, this is the units place, this is the tenths place, this is the hundreds place, the thousands, 10,000s, lakhs, 10 lakhs, crores, 10 crores, Arabs, 10 Arabs. And this is where the commas are typically kept. Now, when it comes to the international system, The places are, this is called, though you can call it units, but otherwise it's called as the ones place. Then you have this as the tens place. This is the hundreds place, which is the same. This is also the same with the Indian system, the thousands place, the 10,000s place. Now from here the difference starts. This comes as the 100,000s place. This is not lakh, this is 100,000. And after that starts their term called million. This is the millions place. This is the 10 millions place. This is the 100 million place. Similarly, we have a billions place, billion. This is the 10 billions place. And if at all there is something, let's say I put a 5 here, this will become 100 billions place. So this is what is the international system. The international system. So if I start from the right, the ones is on the extreme right. After that I have a group. So the ones group contains the hundreds, the tens and the ones. The 1,000, 10,000 and 100,000 is one group. The million, 10 million, 100 million is one group. The billion, 10 billion, 100 billion is another group. So you could see you have to group them with 3 at a time, starting from the extreme right. So you put a commas also. So if this is the same number in the international system, I'll put commas after every 3 digits. So this would be read as 512 billion, 345 million, 678,901. So that is the way we generally read the international system. So the commas are put at the end of every 3 digits starting from the extreme right. So you have to be comfortable both with the Indian system of representation as well as the international system of representation. Then I will bring out the different types of numbers. I want to talk about the different types of numbers. So broadly, I will put them, though you can divide them into various ranges. I'll go step by step. So initially, I'll start with a set of numbers called natural numbers. The first set is actually called as natural numbers. Otherwise, they are also called counting numbers, because those are the numbers that we use for counting. So generally the numbers like 1, 2, 3, 4, so on up to few lakhs, few crores, few arabs. So they are all called as natural numbers. They are the ones that are generally used for counting. The way we represent those natural, any group of numbers, if I want to represent, I can simply, generally the letter that we use for natural numbers is capital N. Capital N is a number, is a notation for natural numbers. And if I want to write out the set of natural numbers, I'll put that within braces, a flower bracket. I'll write 1, comma 2, comma 3, a few of them I'll write, and I'll put some dot 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 dot, which will say that the list continues in this pattern. So this is what is a set of natural numbers. Now, on the top of natural numbers, there is one more group, which is otherwise called as whole numbers, right? Whole numbers. Generally, it is represented with W. The only difference between the natural numbers and the whole numbers is, along with all the natural numbers, it also contains a number called 0. So all natural numbers plus a number 0 is equal to the whole numbers. So the group of all natural numbers along with the number 0 is a set of whole numbers. So if I have to represent whole numbers in a set notation, 0, comma 1, comma 2, comma dot dot dot. So the smallest whole number is 0, whereas the smallest natural number is 1. So that's one more group. Then on the top of this whole numbers, we have another group that is represented by a notation called Z. They are called integers. So if I have to look at whole numbers, they are from 0. But along with the whole numbers, if the negative numbers are also considered, along with the whole numbers, if the negative numbers are also considered, that is what will become the group of integers. So integers contain both positive numbers, all positive counting numbers, all negative numbers, along with a 0. So there is no smallest integer or there is no largest integer, because the numbers can be minus infinite, very small value, minus a large number. So they can start from somewhere, let's say minus 3, minus 2, minus 1, 0, 1, 2, 3, so on. They can go to anything. So there is no smallest value or there is no largest value as far as the integers are concerned. So natural numbers, whole numbers, all of them are a part of the integers. Even a 0 is a kind of an integer. So but it is not positive or negative, whereas all other numbers are either positive or negative. So right now we can talk about this kind of a classification of the numbers. Then sometimes the negative number, let's say I am talking about minus 4. If I use the word absolute value of any number is nothing but I remove the sign. Whether it is negative or positive, when we say an absolute value of a number, I am only bothered about the value, not the sign, plus or minus. I don't bother about it. So the absolute value of minus 4 is 4. The absolute value of plus 4 is still 4. So absolute value generally is denoted within two vertical lines. So the absolute value of minus 4 is 4. The absolute value of plus 4 is also 4. So when we talk about the negative numbers, sometimes it is very much necessary that I have an understanding of the absolute value of it also. So I don't consider the sign, as simple as it. So that is one classification of the numbers that we need to be aware of. Then the other classification, so one classification is natural numbers, whole numbers, integers, etc. The other classification of the numbers is classify them into odd or even. This is one classification. So the odd numbers versus even numbers. Generally, we apply all these to natural numbers only. This classification is not that applicable to the whole numbers or even negative numbers. Natural numbers, we generally classify them or split them into the even numbers and odd numbers. So as you all know, any number when I divide by 2, so there are only two possibilities. The remainder is either 0 or the remainder will be 1. So whenever I am dividing a number by 2, the remainder can be either 0 or 1. If the remainder is 0, I'll call it as an even number, which means it is perfectly divisible by 2. Even number is perfectly divisible by 2. Whereas if the remainder is 1, I call it as an odd number, and this odd number is not perfectly divisible by 2. It leaves a remainder when it is divided by 2. So, if I am talking about some number n, if I am talking about some number n, and any even number can be represented as 2n, means I multiply it by 2, it will definitely be an even number because 2n is perfectly divisible by 2. 2 times n is always divisible by 2. So, any number which is of the form which can be written as 2 into n. Now, if I am talking of 10, it can be written as 2 into 5. If I am talking about 20, it can be written as 2 into 10. So, any number which can be written in the form of 2n, which means 2 into n, is typically called as an even number. Whereas, when it comes to odd number, any number which can be written in the form of 2 into n plus 1 or 2 into n minus 1. If I am able to write a number in the form of 2n minus 1 or 2n plus 1, those are the odd numbers. Now if I am talking about 10, I cannot write it as 2 into, let's say if I am saying 2 into 4 plus 1, it is not 10. 8 plus 1, 9. Or 2 into 5 minus 1, still 9. So 10 cannot be written in the form of 2n plus 1 or 2n minus 1. But think of 11. 11 can be written as 2 into 5 plus 1 or 2 into 6 minus 1. So it can be written as 2n plus 1 or 2n minus 1. So any number that is written in the form of 2n plus 1 or 2n minus 1 will become an odd number. Any number which can be written in the form of 2n, we are calling it as an even number. So this is another classification of numbers. Now, the other classification that comes out is the other classification that I am bringing out is a prime number versus a non-prime number, which is otherwise called as a composite number. So this is also applicable only to natural numbers, not to negative integers or whole numbers, etc. Simple thing, if any particular number has only two factors, that is the number itself and the number 1. If any number has exactly two factors, if a number is divisible only by two numbers, one is the number 1, the other one is the number itself. Those are all called as prime number. So generally a number 2, it is divisible only by 1 and 2. Number 5, divisible only by 1 and 5. Number 17, divisible only by 1 and 70. So any number that is divisible only by the number 1 and the number itself and no other number is typically called as a prime number. But take the case of a number 1. It is not divided, it does not have two factors. It has only one factor. It is divisible by 1 only. Itself is again 1 only. So there are not two, it doesn't have two different factors. So 1 does not come under the prime number category. It's a special category. So 1 is not a prime number. Then when it comes to the composite number, any number which has more than two factors. So means apart from 1 itself, at least one other factor will be there. One other factor at least. It can have more, but it will definitely have one other factor. They are called composite numbers. Now if you look at a number 6, number 1 is a factor to it, number 6 is a factor to it, but 2 is also a factor. 2 3s are 6 and 3 is also a factor. 3 2s are 6. So apart from the number and its apart from 1 and itself, there are a couple of other factors also for that number. They are called composite numbers. A number 25. Apart from 1 and 25, we also have 5. 5 5s are 25. So at least one additional factor is present. They are all composite numbers. So which means 1 does not come under the category of composite numbers also. Because it has only one factor. It does not have two factors. It does not have greater than two factors. It has only one factor. So it does not fall under the category of prime. It does not fall under the category of composite. So it's a special number. So when it comes to the prime numbers, 2 is the smallest prime number. Some of the things for you to remember. When we talk about the smallest prime number, it is 2. And there is only one prime number which is even. What is that number? Again, it is 2. So there is only one prime number that is even. That is also a number 2. Now, there's a lot of interesting things that people talk about when we bring in prime numbers. So some of the things that I would like to bring out, it's better that we remember the list of prime numbers between 1 and 100. So if I start 2, 3, 5, 7, then 9 is not, because 3 3s are 9, 11, 13, 15 is not, 17, 19, 21 is not, 3 7s, 23, 25 is not, 27 is not, 29, 31, 33 is not a prime, 35 is not a prime, 37, then it is 41, 43, 47, 53, 59, 61, 67, 71, 73, 79. They don't come in any other table except one table and the number itself, 89 and then 97. So these are the various prime numbers that are existing between 1 and 100. So some of the things for you to remember: 4, 5, 6, 7, 8, 9, 10, 11, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There are exactly 25 prime numbers in the first 100. So that's an interesting thing that better for you to remember. Out of this whole list, if you see, there is only one even prime number, which is 2. All others are odd. Of course, from 4 onwards, 2 is an additional factor. So that's the reason other even numbers don't come under the category of the prime numbers. Then here a few more important points for me to talk about. There is something called twin primes. Twin primes. Twin primes is nothing but those prime numbers which are separated by a distance of 2 units. So the difference is 2. Wherever we see the difference is 2, we call them as twin primes. 3 and 5 is a twin prime. 5 and 7 is a twin prime. 11 and 13, 17 and 19, 29 and 31, 41 and 43. Like this, you find there are a few twin primes where the difference between the prime numbers is exactly 2. And a similar kind of a concept when there are 3 such pairs, right? When there are three different prime numbers which are separated by a distance of 2, they are called as prime triplets. Prime triplets. So when you see that there are 3 prime numbers, all of them differing by 2, we typically classify them as prime triplets. So you could see the major prime triplet is only this one, 3, 5, 7, and you don't find any other prime triplet, 3 of them differing. So 3, 5, 7 is the major prime triplet that you can simply see. So that's another important point that you can remember. And there is another definition that people talk about is co-primes. Twin primes is those primes which are separated by a distance of 2. Both of them are prime numbers, but they are separated by a difference of 2. But when it comes to co-primes, both of them need not be prime, right? Both of them may not be prime at all. Let's say I am talking about number 9 and 25. Both of them are composite numbers, but they are co-primes. Why? If I see both of them together, they should not have any number other than 1. So if the common factor between both of them is only 1, if 1 is the only common factor between the two numbers, that is what those pair of numbers are typically called as co-primes. So they may be primed separately, they may not be primed separately, it doesn't matter. When we talk about co-primes, we look at the common factors that are existing between the two numbers. If the common factor exists, then they are not co-primes. For example, 12 and 9. They are not co-primes because they have 3 as a common factor between them. So they are not co-primes. But 2 and 73, they are co-primes because they don't have any other common factor except 1. So individually the numbers may be primes, may not be primes, but when we use the word co-prime, we are talking about the common factor other than 1. If they have a common factor other than 1, then they are not co-primes, but otherwise if they don't have any common factor other than 1, they are all co-primes. So this is one more. Then there is a concept called perfect number. Again, we have very few such kind of numbers. So the perfect number is nothing but I take all the factors of that number, right? I take all the factors of that number, add them. If I add them, the total sum should be double that of that number. If the total sum of all the factors comes exactly double to that of the original number, those are the ones called as the perfect numbers. So if I look at the simpler example is the number 6. What are all the factors of this number 6? 1 is a factor of it, 2 is a factor of it, 3 is a factor of it, and 6 is a factor of it. Nothing else. You add all the numbers, 1 plus 2, 3, 3 plus 3, 6, 6 plus 6, 12, which is exactly double to that of the number. So that is where we call 6 as a perfect number. But try the others. Let's say 20. 1 is a factor of it, 2 is a factor of it, next 4 is a factor, 5 is a factor, then 10 is a factor, and 20 is a factor. You add up all of them, 1 plus 2, 3, 3 plus 4, 7, 7 plus 5, 12, 12 plus 10, 22 plus 20, 42. So it's not double that of 20. So because it's not double, it cannot be a perfect number. Then look at the number like 28. 1 is a factor, 2 is a factor, 4 is a factor, 7 is a factor, 14 is a factor, 28 is a factor. You add up all of them, 3 plus 4, 7, 7 plus 7, 14, plus 14, 28, plus 28, 56, which is exactly double to that of 28. So we can say 28 is also a perfect number. You can think of such kind of perfect numbers. You can quickly keep playing around. Take some number, take the factors of it, do some kind of quick calculations of the summation of the factors, and if it comes exactly double to that of the original number, then you can very well classify them as perfect numbers. So this is another concept that you need to be comfortable with. Then the other thing I want to talk of here is the divisibility rules. The rules of divisibility. When do I say a particular number is divided by another particular number? So for each one, we have a quick set of rules. If I am talking about a number being divided by 2, when do we say any particular number is particularly divisible by 2? Every even number is perfectly divisible by 2. Which means the definition of the even number is it should be written in the form of 2n. So every number which can be written in the form of 2n is very much perfectly divisible by 2. Otherwise, the ending digit, just quickly look at the ending digits. They should be either 2, 4, 6, 8 or 0. So if at all any of them are there, then that number is perfectly divisible by 2. Then do you remember what is the divisibility rule for 3? A number is divisible by 3. You simply add up all the digits. Any big number, whatever is the size of the number, it could be in crores, it could be in Arabs, whatever, millions, billions, whatever it is. You add up all the digits. And if this one, even after addition, if the number is big, again redo the re-add up. So let's say I'm talking about a number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2. I add up all the digits 3, 6, 10, 15, 21, 28, 36, 45, 48. Now, if this is too big, again add up all the digits 12. 4 plus 8, 12. So, what I really want to see is if this number is divisible by 3 after I add up, if this number is divisible by 3, then this entire big number is divisible by 3. So the sum of all the digits, if it is divisible by 3, then I say the entire number is perfectly divisible by 3. That's the rule for divisibility by 3. Then, is this number divisible by 4? How do I really assess if this big number is divisible by 4? Simple thing is just check the last two digits. Just check the last two digits. See if this last two digits are divisible by 4. 12. 12 is divisible by 4. It doesn't give any reminder when I divide it by 4. 4 threes are 12. So, because the last two digits are perfectly divisible by 4, this entire number is divisible by 4. So, I have to only check the last two digits, are they divisible by 4? If the last two digits are divisible by 4, then the entire number is divisible by 4. 5. Straightforward. Any number is divisible by 5. I just look at the units digit. If it is either 0 or 5, the entire number is divisible by 5. Now in this case the units digit is 2. So obviously this number is not divisible by 5. Only if it has a 0 or a 5 in the units digit, then the whole number is divisible by 5. Then comes, what about 6? Now, this is where an interesting part comes up. If I have to talk about 6, see if 6 can be written as product of two coprimes. Can I write 6 as the product of two coprimes? I can write 6 as 2 into 3. Both of them are prime and both of them are coprimes. So I can write 6 as 2 and 3, which means any number is divisible by 6 if it is divisible by both 2 as well as by 3. So this whole number is divisible by 2 because the unit digit is an even number. It is divisible by 3 because we have added and we have checked that out. So because the number is divisible both by 2 as well as by 3, it is divisible by 6 as well. So for a lot of divisibilities, we can bring in this kind of a concept. Express it as two different coprimes, and if a number is divisible by both the coprimes, I can very well say that the product is also divisible. Product also divides that number very much perfectly. But you have to express it as the product of two coprimes, not one and itself, but other numbers. You express it as a product of two coprimes. Then if it is divisible by both of them separately, then it will divide them together as well. So that's the rule for 6. The same rule I can apply for 12. Because 12 I can put a rule of 3 and 4. If a number is divisible both by 3 as well as by 4, then I say it will be divisible by 12. Similarly for 15, if it is divisible both by 3 as well as by 5, I say it will be divisible by 15 as well. So wherever I can express the number as the product of two coprimes, I can very well form the divisibility rules accordingly. Then comes 8. How do I assess if a particular number is divisible by 8? Just like, so if you see the pattern, a number is divisible by 2 if the last one digit is divisible by 2. A number is divisible by 4 if the last two digits are divisible by 4. Because 4 is nothing but 2 into 2. Whereas 8 is nothing but 2 into 2 into 2. 8 can be written as 2 into 2 into 2. So the rule for 8 is the last three digits. If the last three digits are divisible by 8, then the whole number is divisible by 8. So in this case, the last three digits are 0, 1, 2, which is 12. 12 is not divisible by 8. So obviously this entire big number is not divisible by 8. So especially if I have to talk about the divisibility by 8, because I can write it as 2 into 2 into 2, I'm only looking at if the last three digits are typically divisible by 8, the whole number is divisible by 8. Then the rule for 9 is similar to the rule for 3. Add up all the digits. After adding up, if the sum is divisible by 9, the whole number is divisible by 9. Just like the rule with 3. So we have added all the digits, it came up to 48. But 48 is not divisible by 9. So this whole entire number is not divisible by 9. Because the sum of the digits is 48. Sum of the digits is not divisible by 9. So this entire the entire number is also not divisible by 9. That's the rule for divisibility by 9. Then for 10, it is obvious. The units place, if it is 0, then it is divisible by 10. Otherwise, it is not. Straightforward. Then comes an interesting one, which is the divisibility by 11. Simple thing I tell you to do is add up the alternative digits. 1 plus 3, 4. 4 plus 5, 9. 9 plus 7, 16. 16 plus 9, 25. 25 plus 1, 26. The first set is 26. You have simply added up the alternate digits. Then add up another set of alternate digits. 2 plus 4, 6. 6 plus 6, 12. 12 plus 8, 20. 20 plus 0, 20. 20 plus 2, 22. So you are taking alternate digits. Alternate digits. So first set of alternate digits is 26, the sum of them. Second set of alternate digits, the sum is 22. Take the difference of these two sums. 26 minus 22. 4. If this difference is either 0 or any kind of multiple of 11, if the difference is either 0 or a multiple of 11, then this whole number is perfectly divisible by 11. Otherwise, it is not. Let me take a number. 1, 2, 3, 4, 5, 4, 3, 2, 1. Is this number divisible by 11 or not? Let's see. 1 plus 3, 4, 9, 12, 30. 6, 10, 12. The difference is 1. 1 is not a multiple of 11. So this is not divisible by 11 at all. But rather than that, instead of 2, if I make this 3. 1 plus 3, 4, 9, 12, 30. 6, 10, 30. 13 minus 13 is 0. Because the difference is 0 or a multiple of 11, this whole number is divisible by 11. If you want to divide it by 11, you should get a remainder of 0. So sometimes if I really want to assess the divisibility rules, some of them that can be really handy for me. So if I remember all these rules, sometimes quick checks of if a particular number is divisible by a particular number, it becomes very easy, right? So as I've already said, for a lot of them the rules are straightforward. Now if I'm looking at 12, 3 and 4. If I'm looking at 15, I can take it divisibility by 3 as well as divisibility by 5. And if I am looking at 16, it can be written as 2 into 2 into 2 into 2. So the pattern is the last 4 digits. If the last 4 digits are divisible by 16, then the entire number is divisible by 16. If the last 4 digits are divisible by 16, then the entire number is divisible by 16. So that is what is the rule for 16. And similarly, if I am looking at 18, I can take 2 into 9. So a number is divisible by 2 as well as 9. It can be divisible by 18. If I am talking about 20, I can talk about 4 and 5 because they are expressed as co-primes. Then similarly, 24, I can express it as 3 and 8. So wherever I can express them as the product of two co-primes, so if the number is divisible by both of them separately and both of them are co-primes, then it is perfectly divisible by the product of those numbers as well. So that's one more important point that we need to understand as a part of this topic. And I hope you all know this division algorithm, the relationship between the divisor. There are four components of a division. There is a dividend, there is a divisor, there is a quotient, and a remainder. So what is the relationship? Dividend is equal to divisor times divisor multiplied by quotient plus the remainder. So even if some of them are there, you can find out the other. So dividend is always equivalent to, so if I am looking at a number 47, let's say the divisor is 5, then it is nothing but 5 into 9 quotient 45 plus 2 is the remainder. You divide 47 by 5, 5 nines are 45, 2 is the remainder. So which is nothing but dividend is same as divisor times the quotient, dividend divisor multiplied by the quotient, and to that answer you add up the remainder. So this is one important point that you have to keep in mind, because a lot of numericals can be solved if this relationship between the four elements of the division are understood. So these are some of the important aspects I thought I should bring as a part of the very basics of numbers. And as we move further in another different topic, I'll bring out a few more important properties relating to the numbers. So as a quick thing here, just as a quick summary, we talked about the digits, the numerals, the place value, the face value, the Indian system as well as the international system of representation, different types of numbers, natural numbers, whole numbers, integers, the other classifications of numbers, even numbers, odd numbers, prime and composite. Within the primes, a few more special cases like twin primes, triplets, co-primes, etc. Then a few odd things like what are perfect numbers. Then we talked about the various divisibility rules for 2, 3, 4, so on. And if at all I'm talking about a divisibility rule for a particular number, if I can express it as the product of two coprimes, then if a number is divisible by both the coprimes, then the product is also a perfect divisibility. So these are some of the important topics that I want to bring out as a part of this session. If you have any further queries on the same, you can very well get back to me by giving me a call on the number that I have given below, or you can very well send in an email to the email address provided below. Thanks a lot for listening to this session. Thank you very much.